we want to notice is that this is not separable. I cannot rewrite this in the form a of x dx plus b of y dy equals 0. Cannot do it. With this in mind now, we want to note, however, that if I had taken t times y and t times x in this right-hand side, this gives me back originally what I started with, which implies that this differential equation is homogeneous. Now what this allows me to do is to incorporate a substitution method for the function y to rewrite this differential equation in terms of a new function, v, and have that new differential equation be separable, which I can solve and then reverse the substitution. So to do this, what we're going to do is we're going to let the function y be x times some new function v. Now what this gives us is that y prime can be viewed as the function v plus x times dv dx using the product rule. And so our new differential equation using these two substitutions give me v plus x dv dx is equal to 2 times xv plus x over x, and already using the fact that x could not be 0 based upon the original differential equation, x in the denominator, this right-hand side can be rewritten as 2v plus 1. Or, rewriting everything, we get that negative 1 over x dx plus 1 over v plus 1 dv is equal to 0. And hence, what we have is we've transformed our differential equation, which was not separable, into a separable differential equation that we can now solve. So we'll clear the screen. Now we solve the differential equation. So to do so, we have to integrate each of the three terms listed in this equation, and easily this would be negative natural log of the absolute value of x plus natural log of the absolute value of v plus 1 equals some constant c. Now if we want to solve for the function v, this would give us the natural log of the absolute value of v plus 1 is equal to c plus the natural log of the absolute value of x. And what we're going to do is take each as the exponent of the exponential function and simplify. So e to the natural log of the absolute value of v plus 1 will just simply give us v plus 1 absolute value. E to the c plus natural log of absolute value of x gives us e to the c times the absolute value of x. Now we have absolute values on both sides. To incorporate or to remove both of these absolute value terms, what we're going to do is we are going to let some constant k equal plus or minus e to the c. This will allow us to ensure with this substitution that in fact what we can do is remove the absolute values from both sides and not affect the equation of the original equality. Now at this point we have solved in essence for v, and we now want to reverse our original substitution so we can solve this differential equation with respect to y. So in our case here, we would have v, or y over x, plus 1 equals k times x. And simply solving for y gives us that y would be k times x squared minus x for some constant k. This is the solution to our original differential equation, y prime equals 2y plus x over x.